So just kind of verify that, what I just... So we're going to complete a table, and then we're going to graph the equation, because, yeah, that's the thing. If you want to graph something on the Cartesian coordinate system, you know, if nothing else comes to mind, if you don't know anything about the graph, always doing a table is always one way to go here. All right, and so here's what it's 3x minus 2y equals 12. Based on what I just said, this is a linear equation, right? In two variables, x to the first, y is to the first. So we should be expecting a line. Let's see if that happens. Here's the table. Similar to one they'll have you do on the homework here. Line 1, we got x is 0. Line 2, I've got y is 0. Line 3, I got y is 3. Line 4, x is negative 2. And line 5, y is 1. They're just going to have us completing a table like this because, as we know, to be a solution or a point on that graph, it has to have what? It has to have an x value and a y value. So when they set up a table like this, you know, they're trying to get you to find some pairs of values. We're just choosing x to be 0. We want to find the y and then do the rest down there. So how would I do that? Well, just like it says, set x to be 0 in the equation. And that's where solving linear equation comes in handy there. Of course, this one's real easy because that's 0, isn't it? When x is 0, we get minus 2y equals 12. Divide off the minus 2, and what do we got? X is negative 6. So x is negative 6 in that their scenario. Okay? When y is 0 is the second line, so we do the very same thing, except in my equation, y is going to be 0 there. Well, similar nice thing happens. 2 times 0 is 0. So my equation then in that case is just 3x equals 12. Divide by 3. Yeah, x is 4. And you get the drift there, right? So just go on down the line, and that'll give us several ordered pairs that we can work on. Now line 3, I've got y is 3, so I do the same thing. Of course, in that case, not as nice a thing happens because 2 times 3 gives me 6, or 3x minus 6 is what I have there. So I have to do a little bit more solving there, but no real biggie there. Just add the 6, divide by 3, and x is 6. Right? Okay. So let's fill the rest out. Line 4, I've got x is negative 2. So be careful. Just have to be careful with signs and keep up with your signs there. That would be 3 times negative 2 would be negative 6. So out of negative 6 minus 2y equals 12. Solve that. What do I get? Add 6. So I have negative 2y equals 18. And I would note there, be sure to keep up with that minus sign. It gets lost real easily. Divide by minus 2. Y is negative 9. And so last but not least, we have y is 1. Which I think I know why I did that one. All right, so 3x, plug in the y to be 1. Yeah, and that's, of course, times negative 2 times y, so it's 3x minus 2 equals 12. So we add the 2, 3x equals 14. Divide by 3, we've got x is 14/3. All right, so far so good. Step 1 down. Completed our table. Step 2 is graph the equation. Now, we do have, everybody got that one? We do have here some ordered pairs, some points that we can plot to graph our equation. First one I've got is 0, negative 6. The x is 0, y is negative 6. Where does that one go? It would be on what? It's going to be on the y-axis. X is 0, y is negative 6. Which makes me think, too, you don't have to have graph paper, but if you want to get some graph paper, that would be perfectly fine. X is 0, y is negative 6, because that helps sometimes in lining up things. All right, then point 2 there's 4, 0. Where's that one? On the x-axis. Right about there. Oh, these others. 6, 3. 6, 3 is x is 6, y is 3. So 5, 6 to the x. 1, 2, 3 for the y. You got negative 2 and negative 9. X is negative 2. Y is negative 9. There. And then, okay, yeah. What about this one? How would I do that one? 14/3, comma 1. Well, might want to do something here. 14/3, mixed number. What about 4 2/3? Or 4.666 repeating, I do believe. Is that right? I believe so. All right. Yeah, so change it over to decimal or a mixed number instead of the improper fraction there. All right, so that would be where? Well, it's a little more than halfway, 4.6, 4 2/3, maybe right about there. And then 1 for the y, so there. And yeah, sure enough, looking at all our points there, looking pretty much like a line. And like I said, you should probably expect all these to do that. So if you got a point, say we did another point and it was way up here, might be something wrong with that point. So if you get a point that's not lining up, you might want to check that one. But all ours are lining up, so the graph then connect the dots and then extend it out all directions, and you have it. There you have it. That's our graph of our equation. All right, so we've seen two so far. Let me talk about then, yeah, so the three actually equations we've talked about so far have all been similar in nature to this one. We had the x term and then we had a y term. I think there was a plus on the others, but very similar on both. This is what's referred to when you have the x terms and y terms on the side there together. It's referred to as standard form of a linear equation. So if it asks for standard form or it says that's what it's looking for, that's what it wants. To get a little more technical about it, these they don't want fractions in standard form. In the other forms there are fractions, but in the standard form they don't like to see fractions. And the x term too, they want to be positive, but we'll talk about that if we need to later on. Okay?